Good evening, students. In today's class, we are going to learn the basic electronics course in which we are going to discuss the digital electronics module 5. So the topics what we are going to discuss today is difference between an analog and digital signal, number systems and conversions from one system to another system. So let us analyze what is an analog signal and digital signal first. Analog signal, it is a continuous time signal which changes over a time period, whereas digital signal is a discrete signal which carries in binary form. And analog signal, it is difficult to analyze, whereas a digital signal, it is easier to analyze. And normally analog signal, it will be represented by a sine wave, whereas a digital signal, it is represented in the form of a square wave. An analog signal contains a huge number of values, either it can be positive or negative, whereas a digital signal, it is having a finite range, that is either it will be 0 or 1. An analog signal has the tendency to get distorted, whereas digital signal has less tendency to get distorted. An analog signal stores the data in the form of a waveform, whereas digital signal, it is stored in the form of binaries. And best example of analog signals are human speech, instantaneous voltage and current. Whereas for discrete digital signals, it is the signals from in a computer, optical drivers and digital phones. So number system. There are 4 number systems exist, and these are the systems which we are using in the digital systems. So it is decimal, binary, octal and hexadecimal. Decimal system, it is basically what we are using it, that is with base 10. So decimal system consists of the data starting from 0 to 9. And for the binary, it is either 0 or 1. It will be representing as either high or low, whereas the base is 2 for the binary system. And for the octal, it is represented in the form of base 8, that is from 0 to 7. And for hexadecimal, it is the data is represented in the form of 0 to 9, and for 10 it is A, 11 it is B, 12 it is C, 13 it is D, 14 it is E, 15 it is F. So the base is 16 for hexadecimal. So these are the 4 basic numbering systems exist in the digital world, that is decimal, binary, octal and hexadecimal. So this is what we have discussed just now. Decimal, it is digits from 0 to 9, base is 10. Binary, it is represented in the form of 0 and 1 and base is 2. Octal, it is 0 to 7, base is 8. And for hexadecimal, it is 0 to F, base is 16. So let us have a conversion between these number systems. So the basic conversion starts from converting a decimal number to binary, then decimal to octal, decimal to hexadecimal. So one thing I can shortly say that how these conversions are possible is any decimal number you take, if you keep on dividing the by 2, and whatever the quotient and remainder you are getting, if you consolidate, you will be getting a binary number. And for the octal, the same decimal number has to be divided by 8. And for hexadecimal, it has to be divided by 60. So first let us see how to convert decimal to binary number. To convert a decimal integer to binary, as I told, we need to divide the given decimal number by 2 and the successive quotients by 2. So the remainders whatever we are getting after dividing the given number by 2, it can be either 0 or 1. So finally we need to keep on dividing until the number you are getting as the quotient as 0 or 1. And finally you have to write the number in the reverse order, to get the equivalent binary number. And for the fractional part, how to convert a decimal fraction to binary is you have to multiply the given fractional part by 2 repeatedly until you are getting the fraction product as 0. So later the values you need to write it starting from the MSB, then it goes up to the LSB part. So this can be explained with the help of an example to make it very clear. So this is the example I have taken. I have taken a number 156.188. So this is a decimal number. You need to convert this decimal number to binary. So how to convert this decimal to binary is, as I told, for the whole part, that is for the integer part, the 156, you need to keep dividing by 2. So just divide by 2 and write the corresponding remainders after dividing the number. So 156 if you divide by 2, that is 78, whereas the remainder is 0. In the right hand side you can mention the remainders. Again the 78 has to be divided by 2. We'll be getting the quotient as 39, remainder is 0. Like that you should keep on dividing until you are getting the quotient as 1 or 0. So once the division is completed, you have to take the numbers starting from down to top. That is, start from the MSB 1, 0, then you go to the up. So it is 1, 0, 0, 1, 1, 1, 0, 0. So this is the equivalent binary number for the given decimal value. Whereas for the fractional part, it is 0.188. As I told, you need to multiply by 2 and record the whole numbers and see that till the end you are getting the result as 0. Till that you need to keep on multiplying by 2. So let us take the fractional part which is given as 0.188. So just multiply with 2, will be getting us 0.376. Now see what is the integer value. Record the integer value as 0 in the right hand side. Again take the remaining fractional part, that is 0.376, multiply by 2, will be getting us 0.752. Record the product, record the whole part as 0 in the right hand side. Take the remaining fractional part which is 0.752. Again you multiply. So this multiplication you need to do till you are getting the till you are getting the product as 0. Otherwise you can restrict to the number of fractional part also for the binary. So I have made some 5 conversions. So after 5 conversions I have stopped it. So then you need to take the numbers starting from the top to bottom, that is from MSB to LSB. So the fractional part, the equivalent value is 0.00110. Then together we'll write what is the equivalent binary number for the given decimal number. Hence it is 1001100.00110 base as 2. So this is how you need to convert a decimal to binary. Again I will repeat, for the integer part you have to divide by 2 till you are getting the MSB as 1, and for the fractional part you should keep multiplying by 2 till you are getting some 5 conversions. Later together you can write it. And for the integer you have to start writing from down to top, whereas for the fractional part it is from top to bottom. These things you need to keep it in mind. So let us see the vice versa, that is converting from binary to decimal conversion. So for that, whatever the given binary number, you write it and see what is the weightage of each binary number starting from the left hand side. So the weightage from the left hand side, it will be 2 power of 0. Then the next binary number you need to multiply with 2 power of 1, 2 power of 2, 2 power of 3, etc. And for the decimal fraction, you need to see the weightage as 2 power of minus 1, 2 power of minus 2, 2 power of minus 3, etc. So this will be explained with the help of an example here. So there is a number given, integer number is given which is 110110001. It is a binary number. This binary number I need to convert to decimal. So for that you need to identify the weightage. So start from the left hand side. The first place you need to multiply with 2 power of 0, that is the weightage is 2 power of 0. The next digit, the weightage is 2 power of 1, then 2 power of 2, 2 power of 3, like that you need to identify the weightage. Then you need to multiply with the given binary number, and then finally you have to add to get the equivalent decimal number. And for the fractional part, the weightages, like you need to start from the right hand side. The weightage is 2 power of minus 1, then 2 power of minus 2, 2 power of minus 3, 2 power of minus 4. Then multiply the weightage with the corresponding binary fraction given and then add it. So I am getting it as 0.6875, and together you can write it as 217.6875 with the base 10. So this is how you need to convert the given binary number to a decimal number. Again below I have listed together the weightages, and after multiplying and adding, again I am representing it as 217.6875 with base 10.